Hey everyone, so the next unit we're working on is actually periodic functions and trigonometry. We're going to start off this unit with the first section, exploring periodic data. The objectives of this unit are to identify cycles and periods of periodic functions and to find the amplitude of periodic functions. Before we can really meet these objectives, it's really important that we go over the vocabulary of what these things are in relation to periodic functions. We're going to define them, and we're also going to look at them in a picture as well. Periodic function, a function that repeats a pattern of y values or outputs at regular intervals. Regular intervals just really means that there's a consistent pattern to what we're seeing. Cycle, one complete pattern. Period, the horizontal length, the distance along the x-axis, of one cycle. Here I've chosen an example to display a periodic function. Now, I very easily could have just made up a unrealistic periodic function, but I chose to use something that is true and a real example, even though it is not a perfect periodic function. So here are some accurate dates. This is with Eastern Standard Time. Our current time zone, our dates are year 2002, and we have the percentage of moon visibility. So on Friday, May 22nd, we will have 0% visibility. This is really because the moon is going to be between the Earth and the sun, so the sun will be shining behind the moon, and when we look at the moon, it will look like it is black. Because the sun is behind it, it's not shining on the moon at all. As the moon cycles around the Earth, okay, in its elliptical orbit, by Friday, June 5th, we'll have a full moon. Then, Sunday, June 21st, we will have another new moon. The full moon, which happens between two new moons, the full moon is when the Earth is between the sun and the moon. So the sun is shining, and all of the light from the sun manages to light up the full face of the moon for us to view from the Earth. So that's what we call a full moon. So it's full visibility. And as you see, I kind of drew in a little bit here for us. So this is what we call the first quarter, where 50% of the face we see is visible, the first quarter, and then the last quarter is over here. So the moon becomes more visible on this side. The yellow creeps in, it's full, and then the darkness creeps in, and it's a full dark moon or a new moon. Now, the cycle and period can be described in this picture here. So we just defined these things. So here we have our periodic function, and again, it's an approximation. The period is the horizontal length or distance along the x-axis between the beginning and the end of a cycle. A cycle is the piece that repeats itself. You can describe a cycle as being between one new moon and the next. We could describe the number of days between one new moon and the next. The length, that will be the period. So the period is approximately 29.5 days. But you could also describe a cycle as being from one full moon to the next. That period is also approximately 29.5 days. These numbers will vary from full moon to full moon and new moon to new moon. The reason that there is this variation in the number of days, minutes, hours between one new moon and the next, or between one full moon and the next, is due to the fact that the orbit of the moon is not a circle, but instead it is what we call an ellipse. These diagrams here show an exaggeration of the moon orbiting the Earth. The Earth is not located at the center of this orbit. Instead, it's at something called a focus point, and there are two focus points that split center of this elliptical shape. In gravitationally bound systems, the orbital speed of an astronomical object such as a planet, moon, artificial satellite, those are naturally occurring satellites, planets, moons, stars, is the speed at which it orbits. The term can be used to refer to either the mean or average orbital speed over the entire orbit, or what we call an instantaneous speed, which occurs at a particular point in the orbit. These graphics that I have added in here are just examples of what an elliptical orbit would look like in relation to speed, just so you can understand the discrepancies with the time between one new moon and the next and one full moon and the next. The maximum orbital speed occurs at periapsis, while minimum speed will occur at apoapsis. Periapsis is when the moon will be the closest to the Earth, for example, and apoapsis is when the moon is furthest from the Earth. So the closer together they are, the faster the moon's orbit, and that's what causes the variation in the exact time or period to describe a full cycle. We could also describe a few other words that we're about to define so that we could kind of be ready for it. One word is minimum and one word is maximum. When somebody asks you to describe the minimum or the maximum of a periodic function, they are asking you to describe the minimum and maximum as it relates to the y-axis. What is the minimum amount of visibility that we can have for the moon? 0%. The minimum amount of visibility, the minimum is 0 in this case. Maximum, what is the maximum visibility of the moon? The maximum in this case is 100%. Not everything works out in this way. We'll talk more about this as we see some examples. Another thing we can describe is the amplitude. The amplitude is going to be the distance from the midline to the maximum, or from that midline to the minimum. That means our midline has to be defined. Based on the word midline, it's going to be in the middle of the maximum and minimum y values. If you look, I keep referencing the y values. I'm not going down here and worrying about dates, okay? So the midline here is at 50%. The amplitude is this distance here. So now we're not talking about a horizontal distance. We're talking about a vertical distance. The distance from 50% to 100% is 50%. The distance between 0% and 50% is also 50%. Therefore, the amplitude of this function is 50 or 50%, depending on how we describe it. If I asked you, how many days, hours, and minutes do we have between the new moon on Friday, May 22nd, and the new moon on Sunday, June 21st, how much time would that be? How many days, hours, and minutes? What if I asked you, how many days, hours, and minutes are there between Friday, June 5th's full moon, and Sunday, July 5th's full moon? How many days, hours, and minutes? I'll give those answers later somewhere in the video. It'll be a little hidden gem or Easter egg somewhere in the video, okay? We'll see if you get that right. Midline, horizontal line midway between the maximum and minimum values of a periodic function. Amplitude, half the difference between the maximum and minimum values of the function. Maximum and minimum values. The output/y value, for which the numerical value is the largest/greatest and smallest, respectively. If you're asked to describe the maximum or minimum value, it's important that you only describe the y value. You don't need to give an x and y coordinate. When we ask for a value, we're really only asking for the output value. Suppose that what we're looking at right now was only a portion of a periodic function. If it's described to you as being periodic, that means that once you describe or define or locate a cycle of the function, that cycle will repeat itself indefinitely in both directions. If this is described as a periodic function and not a polynomial, these points right here, it's very important in how you kind of draw, show, or indicate the arrows. They are not going up forever and ever or down forever and ever. If you see, I kind of show that this is not forever. If I were drawing a polynomial instead, it should be important. It's important to point out that someone drawing a polynomial would indicate that more like this. This would mean it continues up towards infinity forever. However, commonly when someone's drawing a piece of a periodic function, since we can't draw forever, the arrow will look a little bit more like that. Let's see if we can relate these vocabulary words to this picture right here, as well as the vocabulary words we saw a few minutes ago. Let's start with locating the maximum and minimum values, because those should be a little bit easier to spot out without any confusion. It appears that the maximum value is at 6. The minimum value appears to be at 2. Now, how would we go about mathematically determining where the midline is? Not just by the picture, but what actual mathematical formula could we use to calculate a midline? First thing I'm going to do is set us up with a variable to represent the max, min, and midline. We'll call the maximum capital M. The minimum will be lowercase m. The midline we're going to call SA, and I will explain that more when we get to a different section in this unit. If the maximum value is 6 and the minimum value is 2, how can we calculate the midline? If you think of the midline as you thought of midpoint, 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 what do? Add them together and divide by 2. It's really just the average. So what we want to do is take the maximum plus the minimum and then divide by 2. 6 plus 2 is 8, divided by 2 is 4. I am going to change something a little bit, and I'm going to talk about why I'm changing it. The equation of our midline, the equation will be y equals 4. Every equation of a horizontal line is y equals a number. If we're describing just a value, we don't want to use an equal sign because an equal sign indicates a horizontal or vertical line depending on which letter's there. So instead of using equal signs for our maximum and minimum values, I'm actually going to use colons instead. I suggest that if you copied what I had there, that you do the same thing. The amplitude is half of the difference between the maximum and minimum values of the function. The difference indicates that we would use subtraction. If I've subtracted 6 and 2, I would get 4, which coincidentally is my midline. That's not always going to happen, I promise. And then I want half of it. So I'm going to subtract my max and min and then divide by 2. Do you see how the amplitude equation and the midline equation are actually very similar? The only difference is here I'll have a plus sign. Difference, get it? Here I'll have a plus sign, and here I'll have a minus sign. So the amplitude will be the exact same equation with a minus sign. We'll write that down in a second. So 6 minus 2 is 4, divided by 2 is 2. The amplitude is the distance right here, from 4 to 6, or from 4 to 2, and continually repeats itself. When a function is periodic, it makes it very easy to continue the pattern. It also makes it so that we can predict what will happen later on. And you'll see that we're going to be modeling special periodic functions with trigonometric equations in this unit. Amplitude equals maximum minus minimum divided by 2. Here, to save space, I just squeezed it in horizontally, whereas here I stacked as a fraction vertically. The other two vocabulary words that we saw earlier were period and cycle. I could describe a cycle of this periodic function in a few different ways. One way to describe it is, say, from this point right here, I could describe a cycle from this until this right here. If I highlight this piece, I'm highlighting one cycle of the periodic function. Another cycle that I could highlight is from perhaps right here to right here. You may describe a cycle different than the person you check your homework with, than someone who sits near you, than your friend, whoever. However, you can both be right as long as they both have the same period. And again, the period is the horizontal length of one cycle. So let's check the horizontal length of these two cycles. The first cycle, which went from here until here, what is the period of that first cycle we highlighted with the yellow highlighter? And how would we figure it out? You can subtract 8 minus 4, the larger x value minus the smaller x value, and that'll give you the period of that cycle. The period of the first cycle is 4. If we wanted to find the period of the second cycle, it should also be 4. It appears that this one goes from 7 until 11. Both of those periods are 4, so both of those cycles are probably correct.